All right, welcome to part 2 on section 2.3. So we have some word problems, and again, we're just going to be solving these as linear functions. So it says the weight of a newborn is 7.5 pounds. The baby gained 1/2 a pound a month for its first year. What we want to do is find the linear function that models the baby's weight w as a function of the age of the baby and months t. We want to find a reasonable domain and range for the function w. And 3, if the function w is graphed, find and interpret the x and y-intercepts. Didn't say we have to graph it, we just have to figure out what they are. And if the function w is graphed, find and interpret the slope of the function. Again, we can get that directly from our linear function. And then when did the baby's weight was it 10.4 pounds? And what is the output when the input is 6.2? Interpret your answer. All right, so the first thing we need to do is we need to find a function w of t. And so what is that going to be equal to? Well, it gains 1/2 a pound per month. So that's going to be 1/2 times, and it says time is t in months. So that's 1/2 t. And it initially starts at 7.5 pounds. So if we write this in a linear fashion, that's going to be 1/2 t plus 7.5. And again, 1/2 is going to be our pounds per month we gain times t, which is the number of months, plus our initial weight. Now, what does it say? It's for the first year only. So that's from time equal to 0 to 12 months, okay? And so our reasonable domain is going to be, well, a domain, we're going from 0 to 12. That's going to be our time. That's the t. So it's going from 0 to 12, okay? And it includes those. Now, what about the domain? Well, I mean the range. Well, what is the range? Well, that's going to depend on what our domain was. So now we have our function. We can plug in 0 and we can plug in 12, and that will tell us what our range is. So w of 0 is going to be what? 1/2 times 0 plus 7.5, and that's going to give us 7.5. So our lower point on the range is 7.5. And then we have w of 12. Well, that's 1/2 times 12 plus 7.5. Well, half of 12 is 6 plus that's equal to 13.5. So our upper limit is 13.5. And so that would be a reasonable domain and range, okay? Now, if we actually would graph this, we could graph y equals 1/2 t plus 7.5, and it'd be a nice line. It goes up 1 over 2, up 1 over 2, starting at the 7.5. But what we want to do is find and interpret the x and y-intercepts. Okay, well, x is equal to 0. That's going to give us the y-intercept. And when that happens, we have w of 0. Well, we've already found w of 0, that's 7.5. So we won't have to do that problem again, okay? And it says we're supposed to interpret it. Well, so that means at time equals 0, when it's born, basically, it weighs 7.5 pounds, okay? Now, when we have y equals 0, that's going to be our x-intercept. So we'll have 0 equals 1/2 t plus 7.5. So we'll subtract 7.5 from both sides. And so then that says negative 7.5 is equal to 1/2 t. Multiply both sides by 2 over 1. And so t then is going to give us 15, and it's going to be a negative. Well, what does that mean? Well, at negative 15 months, basically, because t again is time, at negative 15 months, it's going to weigh 0. Well, that doesn't make sense. So this is nonsense in this problem, for this problem. Because we can't have a negative 15 months on a baby. You know, that only takes 9 months to start with anyway. So it doesn't make any sense. All right, so now what about then it goes to the slope, okay? So slope is equal to 1/2, right? Is 1/2 t. So m is equal to 1/2. And from that, what does that mean? It baby gains 1/2 a pound per month. So that's really what that means and the interpretation. All right, so then the next question said, when did the baby weigh 10.4 pounds? Well, the weight, WT, is going to be equal to 10.4 pounds. And so we just set that equal to our 1/2 t plus 7.5. Okay, so now we subtract 7.5. And so then we get what? 9, 2 equals 1/2 t. So multiply by 2, multiply by 2. And so then we get t equals 5.8, and that's months. And so we can say the baby weighs 10.4 pounds at 5.8 months. So that's what we would have when the weight is 10.4 pounds. And the last one says, what is the output when the input is 6.2? Well, input is 6.2. That's t is equal to 6.2 months. And so W of t is equal to 0.5 times 6.2 plus 7.5. And so if we plug that into our calculator, we have 0.5 times 6.2 plus 7.5, and that's going to be 10.6. And so we get 10.6 pounds, okay? So, pretty close, and we would expect that because at 5.8 months, it was the 10.4, so just a little bit further, we get the 10.6 pounds at 6.2 months. Okay, so that's what we get for that answer and where it comes from. All right. Here's a different kind of problem. So they give us a graph, and what we're doing is some kind of a profit for a company. And it says the profit Y in thousands of dollars. So the key to remember is when we're answering anything, if we get something in Y, we have to multiply it basically times 1,000. Of a company in a given year T, where T represents the number of years since 1980, is given in the below graph. Find and interpret the slope. Find the linear function y, where y depends on t, the number of years since 1980. Find and interpret the y-intercept and x-intercept. All right, so what do we have? Well, we need to get some points. So I'm going to say this point is 15 and then 150. Now remember that 150 is 150,000, but right now we're just going to use it as 150. And this one is going to be 25, 450. Okay. So I can get the slope from that. And remember, the slope is just the change in y over the change in x. And so if we take 450 minus 150 divided by 25 minus 15, well, what is that going to give us? Well, that's going to give us 300 divided by 10, and that's going to give us 30. So our slope is 30, okay? So interpret the slope. Okay, well, and that means that for every year, we gain basically $30,000. So for every year, our profit increases by $30,000, because remember, it's in thousands of dollars, so $30,000. All right, so we gain $30,000 every year in profit. What's the next one? It says find the linear function y where y depends on t. Okay, so now we want and it's just going to be y. And I guess that we could do y of t if we wanted to have actually in a function notation. And so we're going to have our slope. Well, that was 30 times our t. And now what we need to do is we need to figure out what is the b value. Okay, well, we can't do that just directly. We just can't say, oh, well, it's something over here. We actually have to think about using one of our points. It doesn't matter which one. Maybe we use the top point, and we plug everything in. And so we're going to have to actually do some calculations. So since there's going to be calculations, I'll do the majority over here, and then right back over there. So if we use that one, it's going to be y minus, it was 450, is equal to, our slope was 30 times x, and then it was 25, so minus 25. And so we'll distribute here, and we'll add 450. So y is equal to, and now we're going to get what, 30x plus, and that's going to be what, 750, oh, minus 750, sorry. And then plus our 450, okay? And so then we get y equals 30x minus 300. So that actually then is the equation of the line we're going to use. And so it's 30t minus 300, okay? Because we're going to put it into t's. Here, I was using x's just because I knew then x's and y values. So that is going to be our linear function y of t depending on t since year. And so that would be the whole function, okay? Now, finally, it doesn't say do any interpretation of that. And so now it just says for part 3, interpret the y-intercept. Well, the y-intercept is right there. So negative 300, and now remember the y-intercept is in thousands, so it's going to be thousands, and it's in dollars. So negative $300,000 at the time, basically in 1980, at time 0 in 1980. Okay, so that was our profit in 1980 at time 0. So we're down here somewhere. All right, what about our X-intercept? Okay, well, our X-intercept is when the Y is 0. So we're going to say, okay, I'm running out of space here. So let's go over here and we'll say 0 equals, and then we have the 30t minus 300. So we'll add 300. So that's 300 equals 30t divided by 30. And so t is equal to 10. And so what does that mean? That's 10 years after 1980. And so therefore, in 1990, the profit was $0. Okay, so that's the interpretation of our last one, the X-intercept. So it's going to be $0 right here in 1990. All right, so that looks like all of the questions they asked for. So again, we had to use the line given, find the slope, and then we had to use one of the points on a line. It doesn't matter which one. And from that, we found our function, or it could have been just some y equals mx plus b. And then after that, we interpreted what all the different parts were. So we interpreted the y-intercept, and then we also interpreted the x-intercept. Okay, so let's go to the next one. So the next one says, when hired at a new job selling electronics, you're given 2 pay options. Option A, base salary of $14,000 a year with a commission of 10% of your sales, or option B, a base salary of $19,000 a year with a commission of 4% of your sales. And so what we want to do is, how much electronics would you need to sell for option A to produce a larger income? Well, what we really need to do first is we need to figure out what are the 2 equations for A and B. For A, all right, so if we just put this in y equals mx plus b form, what is our slope and our intercept going to be? Well, this is basically our value. We're going to get this no matter what. So that's kind of our fixed salary. And then we're going to get adding up this much times however much sales we have. So if we call sales X on both of these, 10%, well, we have to convert that to decimal to put it into formula. So that's 0.1. 4%, that's going to be 0.4. So for Y on A, that's going to be 0.1x plus 14,000. And for B, we have Y equals 0.04x plus, and this time we have 19,000. All right. Now what we need to do is how much electronics would you need to sell for A to produce a larger income? And so basically what we're going to do is we're going to say, well, let's solve 0.1x plus 14,000 greater than 0.04x plus 19,000. And so that's what we're going to do. And now we have to solve for x to determine where that is going to be larger. So first off, we'll subtract 14,000 on both sides. And here, I'm going to take the 0.04 over here. So two things in one step. And so that's going to be greater than, and 9 minus 4 is 5,000. And 1 minus 0.04, that's going to be 0.06x. So now I need to divide by 0.06. And so x has to be greater than 5,000 divided by 0.06. So 5,000 divided by 0.06. So we have to make more than 83,333 and 1/3 dollars basically. So we have to make more than $83,333 and we can put 0.33 is fine, or 3 repeating, or if it's 1/2 we can put that as 1/3 because it was a repeating decimal. Okay, so that's how much we have to make more than to get more for option A. If we make under that, then we should probably, or if we make sell less than that, then we should probably choose option B because that'll give us a bigger salary overall due to that fact we have that initial 19,000 and we're only getting the 0.04%. All right, so option A, we should write this out. Option A is better when we sell more than $83,333.33. Okay, so that's where that one would be a greater than. All right, let's see if we have another one. All right, so here Emily and George start at the same intersection. Emily walks west at 8 miles per hour and George walks north at 7 miles per hour. They're communicating with a two-way radio that has a range of 6 miles. How long after they start walking will they fall out of radio contact? All right, so if we call this, and again I drew this so we could have a nice triangle looking thing. If we start at this point here and we go left, that's west. And so Emily is walking west. And she's going at 8 miles per hour. And George is going north, so that's going up, so that's George. And he's going at 7 miles per hour. And we know that the range, when they get so far up and so far left, the range max is 6 miles. So that's max. Okay. So now what do we need to do? Well, that's distance, okay? So distance max is 6 miles. George is walking this way, Emily's walking this way. And so to be able to use a triangle, this is a distance, this is a rate, this is a rate. So that means we have to figure out a time. And that's what they're asking for. How long after they start walking will they fall out of radio contact? And so if we think about it, the distance is equal to the rate times the time. Okay. Well, we have Emily's rate. So Emily, and if we call it E of t, that's going to be 8 times t. We don't know what t is, that's what we're looking for. And George, if we call him G of t, he is 7t. Okay. So we know both of their distances basically, which is our rate times time, and that's a distance, and that's a distance. And so what we can say is, well, this is a distance already, so we don't have to worry about anything here. But let's say we want to just first off work with what is d of t. And remember, what is the Pythagorean theorem? Well, it's a squared plus b squared equals c squared. We talked about needing a Pythagorean theorem on certain problems. This is one where we're going to have to use the Pythagorean theorem. All right, so and what we're going to do is we're going to simplify it first, and then we'll plug in this distance at the end because we know this distance. But first, we're going to use the ones where we have just the rate times time, and so we're going to do that here in a little bit. So d of t squared is equal to, well, it's going to be equal to Emily, her e of t squared, plus George's e of t, or g of t squared, okay? Well, Emily's e of t, that's going to be 8t squared, plus this is going to be 7t squared. So here we simplify, that's 64t squared plus 49t squared. And so what's that equal to? That's going to be 113t squared, and that's equal to the whole d of t squared, okay? But we know what the d of t is equal to, and so now we have to kind of think about how we want to do this. We can plug in and do square roots and all that stuff. To start with, we can plug in our values. So let's just plug in our value. What is the distance here? Well, that's 6. So 6 squared equals 113t squared. So we'll divide by 113. So t squared is equal to 36 over 113. Now, we don't want just t squared. We want the square root of that. We want t, so we have to take the square root of that side. And if we think about that with time, we don't want the negative time. We just want the positive time, because negative time, we wouldn't have any need for that one. And so then we're just going to have the positive square root of that. And so what we need to do now is find out what that square root is. So we're going to take this positive square root of 36 divided by 113. And we get 0.5644. And so t is equal to 0.5644, and this would be hours. Now, do they ask for any units or any minutes or hours? It doesn't really say. So we could say t is approximately 0.56 hours, and that should be good enough. Now, if they wanted in minutes, we could go, okay, well, what is minutes? We would just take that number times 60, and it'd be about 33.9 minutes. So again, depends on if they want hours or minutes, but since we're working in miles per hour, this would probably be the one that they would ask for. But if they decided they wanted it in minutes, all you do is you take it times the 60, and we get our 33.9 there. All right, so here I think is the last one for this section. And so it says there's a straight road leading from the town of Timpson. So this is what we're going to assume. We're going to assume that this point is Timpson. Again, I drew it so I could easily have straight lines. And it's going to Ashburn. So this value up here, that's Ashburn. And basically it's 60 miles east and 12 miles north. And since we're using a coordinate system, okay, we're gonna go 60 miles this direction, 12 miles this direction. So we've gone 60, and if we go over here, that's up to 12. Now, partway down the road, it junctions with the second road, and this is what this second road is, perpendicular to the first. So again, this is gonna be perpendicular, and it leads to the town Garrison, okay? Now, if Garrison is located 22 miles away, which it is, directly east of the town of Timpson, how far is the road junction from Timpson? So what we want to know is, how far is that? Okay. So now what we have to do is we have to figure out all kinds of things. Well, what do we know for units? Well, this is 0, 0, and this one is 22, 0. This one is, what was that one? That was 60, 12, and this was 60, 0. Okay, and so we know all of those, and so what we need to do is we need to find out what that is. All right, so first, let's figure out the slope, because we just kind of drew a line based on, we knew it went over 60 and up 12 when we just drew that line. So now what we need to do is figure out what is the equation of this line. All right, so again, our slope is equal to the delta y over delta x. And so if we take the y's, we'll take 12 minus 0 over, and then we have 60 minus 0. And so that equals 12 will go in there, that'd be 1 over 5. Okay, so this is basically the equation. Y equals, and we have 1/5 x. Okay. Now we know that this line is perpendicular to this one. So that's M1. So M1 is going to be negative 1 over 1/5. And so we multiply by the reciprocal, and it's a negative, so it's going to give us a negative 5 is what M2 is. So M2 is negative 1 over the reciprocal of M1. So what do we know about that? So our M2 is that. Now, we don't know much about anything else as far as we don't know what its intercept is. It's going to be somewhere way up here because, if we look, it goes way, way high. So what we need to do is we need to use a point we do know. Well, we do know that point. So remember, y minus y1, which is in this case 0, is equal to the slope, which is a negative 5 times x minus, and then we have x1 is 22. And so y minus, that's 0, so y equals minus 5x, and multiply that, that looks to be plus 110. Okay, and so that's our equation of this line. So that's y equals negative 5x plus 110. So we know the equations of both of these lines. Now, since we know the equations of both of those lines, what have we done in the past? Well, we set them equal to find out what that point is there. And so if we do set them equal, that says we have, what was that one? 1/5 x equals a negative 5x plus 110. So let's add 5x to both sides. So here we have 5 and 1/5, so that's going to be 26 over 5x equals 110. And so now we're going to multiply by the reciprocal, 5 over 26, multiply by the reciprocal, 5 over 26. Now 2 will go in here, 13, 2 will go in here, 55. 55 times that's 25, 275. So x is equal to 275 over 13. Okay, so we know our x. And so now what do we need to do? We need to solve for y. Well, guess what? I'm going to use this point here because it's going to be a lot easier. And so y is equal to 1 over 5 times 275 over 13. Well, 5 goes in here once, 5 goes in here. What was that? 55 times. And so we get y is equal to 55 over 13. Okay. All right, so now we know this point. Now we have to kind of remember what formula is to figure out the distance between 2 points. And so what we have is our distance formula says It's going to be the square root of something squared plus something else squared. And if we remember, what it is it's going to be basically our change in y. So we can have, say, maybe y2 minus y1 plus the change in x is x2 minus x1. And so if we plug in our values that we found, y2, let's call that, oops, wrong direction, this value here, 55 over 13 minus 0 squared, because our origin is 0, and that's where we're looking for. That's our origin. And now the other one was going to be plus, and that was 275 over 13. Oops, and then minus 0, so I just went ahead and put in the parenthesis, but we'll write it in there. Minus 0 squared. And so then we basically just have the square root of 55 over 13 squared plus 275 over 13 squared. And so if we find that on our calculator, so we're going to have the square root of, and then we'll have 55 divided by 13 squared, and then plus, and we had 275 divided by 13 squared, and I think I wrote all that out right. So 21.573, and so we can go just 21.57, and we were in miles. So that's how far the junction is here. So that was, let's see, 21.57 miles. Now, what decimal places it doesn't really say. So, you know, it could be 21.6 miles, or if we wanted to use, you know, significant figures, you know, 22 miles. So it all depends on how you want to look at it. But that's 21.57 is what I would go ahead and use for that distance from this 0, 0 to the 275 over 13, comma 55 over, and that should be at 13.2. Okay. All right. So that's all I have for this section 2.3.